All right, so let's start. So I'm talking about Atoma Network, and our goal is to pioneer decentralized AI inference for trusted AI. So let's start with what is Atoma. So Atoma is a decentralized compute layer focused on verifiable AI inference and privacy. So what does this mean? So it means that smart contracts can leverage Atoma as an intelligence layer. And therefore, smart contracts can become, really smart, right? They can make decisions by their own, etc. Moreover, we also want to put forth incentives through tokenomics to allow model owners and creators to monetize their creation, like training and deploying new models open source. So let me recall you what inference means. So basically, inference just means execution of an AI model on a given input to produce an output, right? So for example, when you use ChatGPT and you type a prompt, you press submit, you'll get the text back to you, right, an output. And this is basically what we call inference, AI inference. All right, so why do we think this is an important problem? Well, we have seen a tremendous innovation in the realm of AI, in the AI community with ChatGPT and others. And it turns out that most of these models are closed source. So they are under some closed-gated API controlled by some large, big company. On the other hand, so that's a bit problematic, especially for Web3 folks, that we have this motto of open sourcing code. But there is hope because we have seen people like Jan LeCun, which is a Meta chief scientist at Meta, that is proposing, and it's a big proponent of open sourcing models. And we have seen that Meta, they have been releasing open source. They have open sourcing their large language models like Llama 3, which actually it's very, very performant. It's almost at parity with GPT-4. So this allows us to question what can Web3 bring to the space, to the AI, right? To the AI world. How can AI benefit from blockchains and Web3? And it turns out that governance and blockchains are great for governance to put forth incentives and alignments through communities and protocols, right? So governance, reinforcement learning through human feedback, it's great. Blockchains are also great at providing mechanisms for licensing and royalties. So for example, model creators, they can deploy their models and they can therefore monetize them. And this brings some sort of economy that can be leveraged to have an alignment through AI models to become better over time. On the other hand, blockchains, as you might already know, they are not great for deploying heavy compute tasks or jobs. And one of the reasons is because you need to replicate a transaction across a tremendous amount of nodes, or you have to run it through some very heavy cryptographic primitives. So for example, if you want to run even a very small model, like a baby model MNIST on a blockchain, it will be very, very expensive, right? So let's try to tackle this problem. So basically, this is where Atoma enters. So Atoma here bridges the gap between the Web 2 world and the Web 3 world. So on Web 2, we have no verifiability, so you have to trust into some entity, like some big company, big tech company, and basically you just have to trust that the API provides you the code and the thing that it's permit. On the other hand, Web 3, you have the motto, don't trust, verify, right? So basically everything is done through open source code, through replication, through verifiability. And at Atoma, we are building this elastic verifiability consensus that allows you to deploy applications that have zero verifiability up to very, very, very large verifiability, close to what blockchains can provide you. But it turns out that there is an elasticity here. So you can basically deploy applications that have more or less verifiability. And this is the power of Atoma. It's because it allows you to decouple settlement and compute. And if you are able to do this decoupling, then you can run at minimal cost heavy workloads like AI inference, right? And as I already mentioned, the user or the protocol can choose the level of decentralization and cost. So if you want more decentralization, if you want more verifiability, there is higher cost. All right, so here is a graphic how Atoma works. So on the right, you can see like a Web3 user or a protocol, a Web3 user can submit a request in the form of a prompt or even some inputs to run on some code. And this request is basically it's transmitted to Atoma nodes. You can also run like other sort of like compute, not necessarily AI. So the protocol is in the consensus is flexible enough to allow you to run like Rust programs, WASM programs, and I will explain later why it's important. But yeah, you basically submit a request, let's say a prompt for an AI model. You have a bunch of execution nodes. These execution nodes will run the workload. Once they run the workload, they will try to get consensus, not on the state of a ledger, but on the exact output, right? And this relies on some cryptographic commitment that is small enough and can be submitted to blockchain, where there will be a Atoma smart contract deployed, and the smart contract can attest for the validity of the output, given if the nodes have reached consensus or not. Yeah, so basically, to give you a better sense of how this works, is you basically, whenever you submit a request, you can sample a few nodes to run the computation. You can choose how many nodes you will run the computation. So this relies on some sort of replication as well, but you have the control, right? It turns out that you can even do other things, like you can select one node and then with a given probability select other nodes to attest if the first node has done the output correctly. And these sort of like tricks and mechanisms allows you to actually reduce substantially the cost, and through some sort of game theoretical and cryptographic analysis, you can arrive at a protocol that has verifiability even with like minimal cost additional to native compute, as we will see later. And so, of course, this is heavily inspired by modular blockchains and by the mode of modularity. So basically, fully decoupling execution from settlement, you allow yourself, like you allow the protocol to run very high compute loads at a fraction of cost. All right, so as I mentioned, there are a few tricks here and there that allows you to like have some sort of like game theoretical guarantees that the nodes are rational nodes, have no incentive to act maliciously. I just wrote like some fancy mathematical formula, but basically what it says is that you will have verifiability once the probability or the rate of replication is bigger than the thing on the right. It doesn't really matter what does that mean, but it's just like some expression dependent on native cost of compute, the reward being paid to the node, and how much the okay, how much the node controls of the network. And basically, like this formula allows you to see that even, for example, for a considerable amount of applications where you like the reward premium to run inference is not that high compared to the native cost, which is not necessarily always the case, but it is the case in many applications. And a node that controls 10% of the network is substantial. You just need like a replication rate of 0.07, which is really, really small. Of course, if you need like more security, you force the probability to be larger, you pay an additional cost, but at least you have the high security guarantees. You can have security guarantees as close as cryptographic guarantees. So let me tell you a little bit more about our vision. So at Atoma, we not only want to provide this large protocol for deploying AI protocols, but we also want to like put forth an economy for users and businesses to be able to bring their like idle GPU compute online. And this can be done through tokenomics, through subsidizing, acquiring like hardware, and deploying this hardware on Atoma. And basically, this will, in my opinion, will be important because there is a huge lack of accessibility to like a very specialized sort of hardware that is necessary in AI inference, such as like high-end GPUs. So I don't know if you have ever researched or searched on the internet, but the cost of like a AI-focused GPU is pretty high. It's not that accessible for for most users. So we want to kind of like allow to have an economic that incentivizes users to be able to acquire this. And once this is put forth, we are able to basically run like AI workflows. We can have data integrity natively on the network, and of course verifiable inference, etc. We are also very focused on data privacy, and I think we are not data and model privacy, so you can keep both the model weights private as well the data. And we think that this will be very important, and actually we are not that far from having that, and this will basically open the use cases to like countless industries, etc. All right, so I have a slide on the current developments on Atoma. We have basically so far we have deployed. We are a very early startup project, but so far we have deployed major blockchain on-chain logic. We'll make an announcement, a public announcement shortly, and we have integrated with most like the most well-known open source AI models, and we are currently working on optimizing node infrastructure to be able to run like continuous batching of requests and be super fast. And we are actually very inspired by folks at Reth, where they have very optimization, clarity, and focus to basically improve infrastructure, right? Node infrastructure. And we are also in the process of integrating with data storage solutions like IPFS and others. All right, so just talking a little bit about our tech stack. As I mentioned, we have our smart contracts deployed on Solidity. We are also working with on the Atoma network. On the machine learning, we are doing everything in Rust because we love Rust, and Rust has actually an amazing machine learning community, which is not that well known, but it's great. We have both CPU and GPU support, so even for small to medium models, this can be run on MacBook Pros that can be deployed on the network. And we are also working in close collaborations with experts in fields of MPC, trusted execution environments, ZKML, etc. All right, so there are a few use cases. I think I might be running out of time, but just to give you a very brief overview, this can unlock some nice applications in DeFi, NFTs to generate content, etc., gaming, and of course DAO. DAO governance and whatnot. And moreover, like Atoma becomes like the right framework in our view for deploying what we call AI agents. And you might remember previously, let me see if I can show you again, we had this slide where we had like not only users can plug, like they can submit requests for AI models, but you can also submit inputs to be run on some Rust code or Python code, WASM code, Solidity. And this can go through the consensus in the protocol. So basically, you're able to compose a system, right? You can not only have AI inference, but then you can run code as well. And this is especially important for smart agents, right? Because you might ask, like, your AI model, well, I need to solve this task, allow me to help me doing so. And the best way to do so is to generate the code, a precise set of logic that can be run and be executed, right? So if the LLM produces the code, this code can then be executed by the nodes. And basically you have like this sort of complete automation process with verifiability. And just to finish the talk, we are also like looking into the tokenomics and how we will reward like compute providers, model creators, etc. And this will be empowered by Atoma token. And yeah, that's will also serve the purpose of governance and as I mentioned previously, subsidizing compute. And that's all. Thank you very much.
For questions?